Problem 12.61 involves this system right here. A small block B fits inside a lot or a slot cut in arm OA, which rotates in the vertical plane at a constant rate. The block remains in contact with the end of the slot closest to A, and its speed is 1.4 meters per second for angles at theta greater 0 degrees but less than 150. Knowing that the block begins to slide when theta is equal to 150 degrees, wants us to determine the coefficient of static friction between the block and the slot. Okay, so the givens are that V then is 1.4 meters per second and that theta ranges here, and I'm going to call L this 0.3 meters, which is the length of that bar. If we do a free body diagram on the bar, on the object of the block B, right here it is. I've got these other reference points in here just to give us some angles. We ask ourselves the question, is there force of gravity acting on the object? The answer is yes, it's mg. And I drew it so that it's in that more of a vertical type position. So anyway, the normal force on it would be perpendicular to the length of the rod. The rod is represented by this direction right here. And then the frictional force would be opposing the motion of it trying to move away from point A there. So there's the frictional force. I'm going to call this my E normal direction and E tangential directions right here. So if I do second law here, Newton's second law, some of the forces in the normal direction equal to M times A normal. And when we look for the normal direction right here is, well, it's going to be mg times cosine of, I'm sorry, on the normal direction, yeah, it's going to be mg times cosine of theta right here, minus the frictional, and that's equal to M times A normal. So that's mg cos theta minus the frictional. Frictional going to be mu s times the normal, and that's going to be M then, and A normal is going to be V squared over L. It's a normal acceleration. So some of the forces in tangential equal to MA tangential, so we have N minus, and the direction here is going to be minus mg sine theta, and that's going to be equal to M times A tangential. But the tangential acceleration is 0 because this is all moving at a constant speed. It's driven. So we have that N then would be equal to mg sine theta. So if we take that information and plug it into 1, we have mg cos theta minus mu s mg sine theta equal to mv squared over L. Then the m's cancel out all the way through, and mu sub s is equal then to, it's right here, so it's going to be g cos of theta minus the v squared over L right there, and then divided by g sine theta. When you plug all your numbers into it, you get 0.400.